In the previous class, we had discussed about voltage. What is voltage? What is the SI unit of voltage? And what is the meaning of 1 volt, etc. Okay. So already you know what is the potential difference or voltage. So potential difference or voltage is nothing but it is the work required to move charges from one point to another point is known as voltage or work done. And we measure voltage or potential difference. Okay. We measure that potential difference in volts, right? So we mean the SI of voltage or potential difference is volt. Okay. See, actually it is not volt. Actually, see, we know the formula. Potential difference V is equals to work done divided by charges. Okay. So we measure work done in joules, in charge in coulombs. So the SI of work done is joules per coulomb. Okay. To move electrons from one point to another point, or to move charges from one point to another point, how much work you will do. So that gives the voltage. So that is the voltage or potential difference. Okay. So now this is the SI joules per coulomb. Next of this one, in the honor of that scientist name, Alessandro Volta, we use volt as the SI unit of voltage or potential difference. Okay. Then what is the meaning of 1 volt? What is the meaning of 1 volt? So 1 volt is very simple, right? See, when you will get 1 volt equal to 1 volt equal to 1 joule of work divided by 1 coulomb of charge. Then only you will get 1. Why? Because 1 by 1 equal to 1 volt. Correct? So the meaning of 1 volt means if 1 joule of work is done, to move 1 coulomb of charges from one point to another point. Okay, so that is 1 volt. So clear? So this one we have discussed in the previous class. So in this session, we will study the relationship between a current and voltage. Okay, current and voltage. So now we know about current and voltage. Okay, so today we will study the relationship between current and voltage. So already we know what is current. Current is nothing but it is a rate of flow of electric charges, or so how many electrons are passes through particularly in a given time. So that is called electric current. Then what is potential? Then what is potential difference? So potential difference nothing is the work done to move unit charges from one point to another point. Already we know what is the meaning of 1 ampere. So if okay, see, if 1 coulomb of charges passes through in 1 second, so then we can have 1 ampere current. Okay, then if 1 joule of work is done to move 1 coulomb of charge, so then we can say that is 1 volt. Okay, so now we should study what are the relationship between voltage and current. Okay, see, for that just take one circuit. Okay, one simple circuit. Okay, see, take this is one conductor. Take conductor means take one bulb or fan or whatever. Okay, and it is connected to one battery. Okay, so here I will connect one current. Here I will connect ammeter to measure the current. Okay, better I draw here. Clear? So then I will connect one voltage here, one voltmeter to measure the voltage across this conductor. Okay, I will call this as X and Y. Say this is 2 volt, this is ammeter and voltmeter in parallel. Why? Because voltage means it calculates the work done in work done for moving the charges between 2 points. So now this is 1 point, another 1 point. Okay, so that's why we should connect voltmeter in parallel. Okay, see here. Now I am passing voltage ampere. Okay, so take one, make one table here, voltage and current. Okay, so first one, see here. First I am passing 2 voltage current. How much? 2 voltage. Okay. Now, say I will get 1 ampere current. Just imagine, take some rough values. While doing practically, you will get the exact answer. No need to get when you pass a 2 voltage and you will get 1 ampere. Okay, it is not like that. Just I am taking examples. See. So now I am passing 2 voltage. So here this voltmeter it shows 2 volt current, and this ammeter it shows 1 ampere current. Next, take the ratio of voltage to the current. That is V by I. That is V by I. So what is the answer? Then 2 by 1 is equals to 2. Okay. Next. So second case, I will take 4 voltage. I will add one more cell. Okay. I will add one more cell. So now this is also 2 voltage. Total 4 voltage. Positive and negative. Clear? So now I am passing 4 volt, right? And so just imagine here this ammeter it shows 2 ampere current. 2 ampere. Now once again take the ratio. So 4 divided by 2 is equals to 2. Okay. So next I will pass 6 voltage. Means I will add one more battery. Sorry, one more cell. Okay. So now total 6 volts. So now here in this ammeter it shows 3 ampere current. 3 ampere current. So now take the ratio 6 by 3. 6 by 3. So we will get once again we will get 2. So next I will pass 8 volts. Okay. I will add one more cell. So now total 8 volts. Okay. So here this ammeter it shows 4 ampere current. 4 ampere current. Okay. So 8 by 4 is equals to 2. Okay. So add one more battery. I will add one more cell. So total 10 volts, and this ammeter it shows say 5 ampere. 5 ampere. So 10 by 5 is equals to 2. See, just observe here. See, here we have got same as right here also 2. Okay. See, the ratio between voltage to current is we got 2 in all the cases. Okay. So now tell me, just imagine what it indicates that the answer is the same answer. Okay. What indicates that same answer? See, I have used the same conductor. Are you getting my point? See, just imagine, say this is one bulb. Okay. This is one bulb. Okay. See, while supplying 2 voltage, I have used the same bulb. While supplying 4 voltage, I have used the same bulb. While supplying 8, 10, 6, I have used same bulb only. Okay, I have not changed the conductor. Are you getting my point? Okay, I have not changed the conductor. For in all these cases, I have used same conductor. Okay, but while taking the ratio between V to the I got same answer. What it indicates? Just think what it indicates. See here, we can say that when you change the voltage, then current changes. Definitely, right? When you change the voltage, current changes. Okay. So clearly, we can say that voltage is directly proportional to current, or current is directly proportional to voltage. Clear? Okay. So here we can say that voltage is directly proportional to the you know, right, what is the meaning of directly proportional and inversely proportional? Because in the previous year you had studied in your physics part and also you studied in the mathematics. What is the meaning of directly proportional, directly proportional and inversely proportional? Okay, see here I say that voltage is directly proportional to current. Means when you change the voltage, see, when you increase the voltage, current also increases. When you decrease the voltage, current also decreases. So that's why we can say that voltage is directly proportional to current. Okay, you know, so now we call this as a proportionality symbol, right? So what is that? That is the proportionality symbol. You know, right? To remove this proportional symbol, we should have to introduce one constant. Okay, to remove this proportionality constant, we should introduce one constant. Okay, so I will take that R. Okay, so now I will take this R is the constant of proportionality. Clear? See here I have passed 2 voltage, I got 1 ampere. Here I have passed 4 voltage, I got 2 ampere. Why not 4 ampere? Okay, and what this constant I have taken here R, right? What it indicates? Okay, yes. Before answer for this question, you know, for example, take one fan or a computer or TV. If you use for those devices for a long time, after using a long time, when you touch those devices, you can feel some kind of heat, right? You know, if you take your mobile, if you use for a long time, okay, then you can feel some kind of heat. Then if you take a TV, if you watch that TV for 1 or 2 hours, when you touch that TV backside or front, then you can feel heat, right? Why? See, you have not passed any heat, just you have passed voltage, correct? But if you use for a long time, then you can feel heat. For that question, this is the answer. This R is the answer, which means here. Okay, so this is very important. Listen here. See, you are passing voltage. Voltage means what? You are sending some electrons. Okay, electrons will move from negative side to positive side. Clear? Electrons are moving from negative to positive. Okay, just imagine you are passing 100 electrons. See, this is I am taking just example. You know, 1 second, billions of electrons are passes from one side to another side. Okay, I'm just imagining I'm taking 100 electrons. Okay, so 100 electrons they will move through this conductor. Okay, but while coming this side, say just imagine you will get only 80 electrons. Only 80 electrons will come. What about the remaining 20? Okay, the remaining 20 electrons, they will collide. What is that? They will collide with the neighboring atoms. Okay, they will collide with the neighboring atoms. So now this conductor means that it is also wire, right? Inside we are used wire only, right? So inside, some while moving, some electrons they will collide with the neighboring atoms. For example, say this is a wire. Okay. See, here one atom, so here one atom, and here one atom. Okay, so just here all the electrons are revolving here. All the electrons are revolving here. Okay, so now you will pass one electron. So now you will pass some electrons. What will happen? So you know, when you bring one electron, another electron, both will repel each other. Okay, so what will happen? That electron it will jump to the neighboring atom. Once it is repulsion takes place, it will jump to it will move. But see, we will pass at a time millions of electrons, right? See, some electrons they will move directly. Okay, they will move directly from one point to another point. But some electrons, while moving, they will collide with the neighboring atoms. They will collide with the neighboring atoms. So we can say that. So there is some kind of opposition is right where for the movement of the electrons are moving here, some kind of opposition here, correct? Okay, so due to that what heat is produces in the conductor devices. Okay, So clear, right? Why when you use devices for a long time, why when you touch those devices you can feel heat, right? So that is due to the collision of the electrons with the neighboring atom. Means while moving through the wires, they will face some kind of opposition. They will face some kind of opposition. Say just example, when there is no teacher in your class, okay, some students are simply they will keep quiet time, they will read, they will do their work. But some of the students, what we call in Kannada kidigedigalu, okay, what they will walk here and there, they will disturb others, correct? So here also said some electrons they will move themselves, but some electrons they will collide with the neighboring atoms. They will face some kind of opposition for their flow. Okay, so in that case, what that collision means, what? See, in 1 second, not only one or two electrons. See, electrons are very tiny particles, right? Yeah. See, when two electrons collide, then what is their heat? But in 1 second, billions of electrons are passes, right? If you take the average of all those billions of electrons, then you can feel heat. Okay, so that heat is produces due to the collision of the electrons with the neighboring atoms. Okay, so they will face some kind of opposition, right? Okay, that opposition is called resistance. Here R means what? It is a resistance. Okay, resistance means what? Flow of opposition of electric current. Okay, what do you mean by resistance? Resistance means flow of opposition of electric current. Just imagine you will pass some 100% energy. You will pass 100% energy, but you won't get 100% energy. You will get say just only 20% or 25% amount of energy. Then what about remaining energy? That remaining energy is converted into in the form of heat energy. Okay, so clear, right? What is this R? Here R means resistance. Resistance means the flow of opposition of electric current. But see, in the previous class we had studied what electrons they will move through wire, then it constitutes the current. While moving through the wire, some electrons they will collide with the neighboring atoms. So that's why there is some kind of opposition is there. Their path of those in the path of the motion of the electrons. Okay, so that's why while moving they will face some kind of opposition. So that opposition, flow of opposition is called resistance. Okay, now coming back to this point, then what this two indicates, which means here we have used one device, right? Okay, here we have used one device. So now it opposes only two. We'll discuss later. Okay, say 2 ohm. Okay, we measure a resistance in ohm. We measure resistance in ohm. We'll discuss later what is ohm, what is the meaning of 1 ohm. Okay, so here we call this is 2 ohm, 2 ohm, 2 ohm, and 2 ohm. Okay, so now listen here. Here we obviously we got 2 ohm, right? So now if you pass 2 voltage, or if you pass 10 voltage, if you pass 20 voltage, if you pass 100 voltage, if you pass 50 voltage, okay, the flow of opposition from this device, the flow of opposition from this bulb is only 2 volt. Okay, if you pass 10 voltage, 12 voltage, 15 voltage, 25 voltage, 30 voltage, 35, 100, 80, 90, whatever it is, but it opposes only 2 voltage. In Kannada we can say that ಎಷ್ಟು ಬೇಕು ಅದಷ್ಟು ಮಾತ್ರವನ್ನು oppose ಮಾಡುತ್ತೆ, like that. Okay, so which opposes only 2 ohm. Okay, so we measure that resistance in ohm. Okay, then what is the meaning of 1 ohm? What is the meaning of 1 ohm? See here you got 2 voltage. Okay, see here you use see, first we will pass out 2 voltage. At that time we will use one more conductor. While passing 4 voltage, if you change the conductor, then this value also changes. Are you getting it? See, for 2 voltage, 4 voltage, 6 voltage, 8 voltage, 10 voltage, in all the cases we have to use the same conductor. Then only you will get the same answer. Okay, but while 2 ampere if you use one conductor, for 4 ampere if you use another conductor, then you will get different value. Okay, so clear, right? What is this this constant value represent? Which represents the flow of opposition. Okay, flow of opposition. Now, what is the meaning of 1 ohm? What is the meaning of 1 ohm? See, you have one conductor. Okay, here you have one conductor. Okay, the voltage across this conductor, if it is 1 volt, and current passes through this conductor, if it is 1 ampere, then we will say that the flow of opposition from this conductor is, that is 1 ohm. Clear? Are you getting my point? What is the meaning of 1 ohm? See here, we got relation. First, we got V is directly proportional to I. To remove this one, we have introduced one constant, that is R. Okay, now bring I this side. So V by I is equals to R. R is equals to V by I. So here, what is R? R means a resistance. Resistance means it is a flow of opposition of electron. Okay, so now here, see, this is, we measure resistance in ohm. We measure resistance in ohm. If the voltage across this device, if it is 1 volt, and current passes through this device, if it is 1 ampere, then we will say that this is equal to 1 ohm. Okay, so this is equal to 1 ohm. So ohm is the scientist name, that is the George Simon Ohm. Okay, see, instead of using V by A, I will ask what is the extent of resistance according to this formula. Voltage by ampere is the extent of resistance. Instead of this one, we use ohm. Okay, so clear, right? Okay, see, this is known as Ohm's law. Okay, see that scientist George Simon Ohm, he founded the relationship between voltage and current. Okay, so according to him, his law states that the voltage is directly proportional to the current. Voltage is directly proportional to the current, and provided the temperature remains the constant. Okay, provided that temperature is constant. See here. Okay, see here. Now we can state that Ohm's law. The potential difference V across the ends of a given metallic wire or conductor, whatever it is. Okay. Sorry, the potential difference V across the ends of a metallic wire, okay, is directly proportional to what? Current I, provided that temperature remains same. In simple way, we can say that voltage is directly proportional to current. The provided temperature should remain same. Okay, the temperature remains constant. Clear? Why? Because see here, now here you got two terms, right? See, you are doing this experiment in say one room. Name of that room is say A. You are doing this entire see, you are doing this experiment in a room A. Okay, and in this room the temperature is 30 degrees Celsius. 30 degrees Celsius. See, you will do the same experiment. You will use the same device, but you will do in another room. Say B. And here in room B, the temperature is 45 degrees Celsius. 45 degrees Celsius. Here, while doing experiment in room A, you got answer 2, right? You got answer 2. But while doing in room B, maybe you will get 2.5 or 3 or maybe 4. Here you got 2, right? But if you do the same experiment in B, maybe you will get 2.5. Why? Because there 2, here 2.5. Why? Because the temperature changed. Okay, when you change the temperature, then this value also changes. So the Ohm's law, okay, Ohm's law. If you want to verify that Ohm's law, that temperature it remains constant. Okay, if the temperature is constant, then only we can use Ohm's law. Otherwise, we can't. When you change the temperature, then the relation between voltage to current also changes. Here you got 2, right? Just imagine here while doing 2.5, then you will get 2.5 only. If you get 3, then you will get 3 ampere only. Okay. So this is Ohm's law. What is the Ohm's law? The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current through it. Okay, directly proportional to the current through it, and provided its temperature remains constant or same. Okay, here the temperature remains constant or same. So this is Ohm's law. Okay, so now I think so now we know what is the relationship between voltage to the current. So when you increase the voltage, when you change the voltage, then current also changes. When you increase the voltage, current also increases. When you decrease the voltage, then current also decreases. So clear, right? So in this class, we have studied the relationship between voltage and current. Then we have studied one more point, that is resistance. So what is resistance? Resistance means it is the flow of opposition of electric current. See here, now this is the symbol of resistance. This is the symbol of resistance. Okay, see, just imagine its value is, say, I will say 4 ohm. Okay, 4 ohm. 4 ohm. Okay, see, if you pass 10 or 12 wattage, see, it opposes only 4 ohm value. Okay, it is a fixed. You know, once they manufacture this device, that's its value is fixed. But we have studied, right? This is a symbol. Hope you remember this one. Okay, if you use this one here, you can change the values. Here you can change the values. Say one. Just imagine you will get 1 ohm to 1000 ohm. So here you can adjust for this one 2 ohm or 3 ohm or 90 ohm, 900 ohm or 99 ohm or 500 ohm, like that you can adjust here. But here, if you see, if you take one 4 ohm ampere, then you will get to 4 ohm value only. Okay, then what is the use of these devices? See, what is the function of the resistance? Which opposes the flow of electric current. Okay, see, just imagine. I have one small bulb. I have one small bulb. To blink, say it requires only 1 voltage. Okay, to glow, see, this bulb needs what? 1 volt, 1 voltage. But you have one device or you have one battery, and its value is say 5 volt, which supplies us 5 volt. Now, what will happen if you connect this one? So definitely it bursts, right? It blasts. Why? Because you are passing excessive voltage. Now, but I don't have any other options. I don't have 1 volt or 2 volt battery. But I have to use this one. How to use this one? So here, if you use one resistance according to one value, see, you can't use all the resistors. Okay, the basis of the value. If you use one resistor, then you can reduce. You can reduce voltage. Okay. See here, I will show it in a diagram. Bulb, and here if you use one resistor, you can connect here or here also you can connect. Okay. So now here you are passing 5 voltage, and here same. For the bulb to glow, it requires a 1 voltage. So now using this, what is the function of this resistor? The which opposes this element, which reduces this value. Okay, maybe we will get 1 voltage here. Okay, which opposes the 4 voltage. Correct. So this is the reason why we use resistors. So resistors means what? Just to reduce the voltage. To reduce the voltage, not voltage. In terms of it just reduces the current. Okay, it reduces the current. Now, see here. So we got form, right? V is equals to IR. See, this is very important relation. Okay, see here, it is very easy to remember. See, very important relation. V V means very, I means important, R means relation. Okay, very important relation. See here, now we can write this formula as V I is equals to R. Okay. See now I will increase the resistance. First I will use, see, in one circuit. Okay. See here. First I will use 2 ohm. Okay. I will use 2 ohm, or we can write this relation as say V by R equal to I. See, when you increase the resistance, what about current? When you increase the first, I will use 4 ampere. Then I will use 4. So first I will use 2 ampere. Then I will use 4 ampere. Then I will use 6 ampere. Whatever current, the current increases or decreases. Now see here, voltage is directly proportional to current. But what about resistance? Resistance is inversely proportional to current. Are you getting my point? Resistance is inversely proportional to current. When you increase the voltage, current increases. But when you increase the resistance, then current decreases. Okay? When you increase the resistance, then current decreases. When you decrease the resistance, decrease the current, then when you decrease the resistance, then current increases. Okay? So current is inversely proportional to resistance. Okay, keep it in your mind. When you increase the voltage, current increases, but when you increase the resistance, then current decreases. Or when you decreases the current, sorry, when you decreases the resistance, then current increases. Okay. So now we will discuss a small problem. See the diagram of very important. Okay. See, earlier we got one where in that table we got two, right? See, if you plot the graph for voltage to the current, okay? If you plot the graph for voltage to the current, if you take the voltage in this axis and current in this axis, then you will get, definitely you will get this kind of graph, straight line. Why? Because while taking ratio V to I, you got same answer, right? So that's why you get this kind of graph. Okay. For 2 marks, they will ask them draw the Ohm's law electric circuit for studying Ohm's. Okay, they will ask to draw the electric circuit for studying Ohm's law. At that time, you have to draw like this. X, Y, current. See, current direction is from positive to negative. Okay, and here connect one ammeter, positive, negative, and this is positive and negative. Here, so put the current direction. So this is the schematic diagram to study Ohm's law. Okay, and they will ask what is the and here you have to use one key also. Key means what? Switch. Okay. So what is the statement of the Ohm's law? The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it. Okay, provided its temperature remains same or constant. Okay. Yes. Now we'll discuss one small problem related to that V equal to IR. Okay. See, this is the problem. So I will leave this problem for homework for you. Okay. So find the solution here and send it to me in WhatsApp or in a WhatsApp group. Okay. The potential difference between the terminals of an electric heater is 60 volt when it is draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 voltage? First, understand the question. Here, heater they have used. Heater means, see, all the devices they have some amount of resistance. If you take bulb, that bulb also opposes. If you take a fan, that fan also opposes. All the conductor, all the devices they will oppose us. Okay, they will oppose us the current. If you take bulb, fan, TV, whatever. Correct? Yes, I'll continue tomorrow.